So I'm going to talk a little bit about our company first, and then I'll tell you about how we've been using Qt to build our cross-platform product. Name of the company is Fidelity, and basically we built an open source cross-platform, fully buildable virtual reality metaverse. So you can actually go to our GitHub today. You can go to our home page today and download the software. It's available in beta. And basically, the important things about this is that we work cross-platform with all the various VR hardware out there, HMDs, hand controllers, things like the Leap hand controllers, things like the Oculus Touch, things like the Vive. We run on Windows, Mac, Linux. So cross-platform's been pretty important to us from day one, and Qt was the platform that we chose to make that process a lot more straightforward. The thing I'm going to talk about today is mostly about how we've used Qt to build user interfaces in virtual reality. But actually, we use Qt throughout our platform as basically a core component for our data structures, for our networking layers, for our multimedia layers. So we use it pretty extensively. A couple things that are interesting about virtual reality is how the user interface models work. And honestly, we've experimented throughout the years on a lot of different approaches. We run on both desktop as well as in headsets, and so that's been this interesting dynamic of how do we present user interfaces that make sense in a desktop environment, and how do we make those make sense in a three-dimensional headset environment. Again, what is high fidelity in particular? It's a shared virtual reality experience. It's very important. So you download High Fidelity, you connect with a friend, you might be across the internet, across the world from each other, and both of you are going to be in the same shared space. You're going to be able to interact with each other, you're going to be able to talk to each other with minimal latency in very high fidelity spatialized audio, and you're going to be able to actually interact with objects in the world. They have physics, you can grab them, you can edit them, you can change them, and all this is happening in real time, low latency. One-to-one presence is critical to our product. Real-time, low latency, that's the key to that. It's a collaborative environment, collaborative content creation. And the other thing that's really important to us is we actually allow you to run your own server. So this is not like a hosted environment. You actually, when you get our software, you're actually running a little server stack, and your friends can connect to it, and you can interact with each other in your own domain. You can, of course, run it hosted. That's why we're cross-platform. So, for example, again, in the cross-platform vein, another thing that's Qt has been important for us is us being able to basically deliver these services, consistently across Mac, Windows, Unix, and even on Android devices as well. And one of the pieces of our system is this notion of the shared computing fabric as well. So as you can imagine, having a solid cross-platform library and having paradigms that we can work with consistently across platforms is pretty important to our technology. Here's a little screenshot. Actually, I think Philip Rosedale, our CEO, gave one of the keynotes this morning and probably showed a video of this working in real time. So, as you can imagine, when you're working with virtual reality, one of the things that's really compelling is you're actually in the space. A lot of there are now multiple hand controllers out there, so you actually can pick things up and you can interact with things. And this sort of really kind of pushed the boundaries of how we think about communicating user interfaces to people. One of the ways that affects the experience is not only do you have sort of user interfaces that are about tools for building things, but you also want to let those things kind of disappear when people are actually engaging with the world and engaging in the environment. And so, for example, we have a bunch of tools that allow someone to build an environment. This sort of hyper Candyland miniature golf environment is actually a real immersive 3D environment that somebody built using the traditional types of selection and editing type tools you might see in an editing package like Maya or Blender. And then they're actually able to go into the world and pick up that golf club and actually hit the ball across that field. And so as you can imagine, thinking about how do we present user interfaces that don't get in the way of the experience, that don't block the experience, but at the same time are useful for for people that are trying to do detailed work. That's been one of the challenges that we've faced, and Qt has been able to be an integral part of our solution for doing that. Because of the hand controllers, you can actually do things like pick up something like a pen and write on the wall, or you can actually grab something and pull it and twist it. That's definitely affected the way we think about user interfaces. So the challenges. As you can imagine, most user interfaces, most people think about user interfaces as being built to work on a desktop environment, to be used with a mouse and a keyboard. And we actually have a lot of people that want to work in virtual reality in that way. And so there's a lot of user interfaces that people are used to thinking about, and a lot of user interface designers are immediately going to sort of gravitate to the idea of putting something in a two-dimensional environment in front of the user so that they can interact with them. And some of those concepts that we want to expose into the virtual reality metaverse, they do sort of have a very natural inclination towards things like text. As you can imagine, if you're searching for something, it's your natural way of wanting to search for something is going to be to type it in and interact in that way and search for things in that way. And so our first cut at implementing those types of features naturally are going to have a very much a two-dimensional text interface-like feel to it. As you see, this is a screenshot here of essentially a discovery mechanism where you can kind of search against domains, and based on keywords, it'll show you either people that are up in an area, or maybe photos that people have taken in an area when they were interacting with a space, and those keywords are useful in that. But the problem with this is that it does sort of, it's kind of like that HUD appearing in front of your face, and that's definitely breaks the presence that you'd have from virtual reality. Today, this is still what we're using as one of our primary interfaces, and certainly I'll get into a little bit of the technology behind how we do this, but as you can imagine, we use Qt to do this sort of user interface presentation. But it's interesting because it's exactly the type of thing that we'd like to try to avoid as we let people be immersed in the environment. So the uglier side of controls in virtual reality is that they do break that presence. What you see here, I mentioned that there's sort of in-world tools that are very much like you'd think of as in Photoshop or any kind of editor tools. The idea of selecting something and grabbing it. We've implemented all that functionality using Qt. We actually, one of the most powerful things that the choices that we made early on was we have a core layer that's written in C++. But we actually quickly integrated the Qt JavaScript layer so that we could actually then build on top of that core platform using scripting languages, and then basically allow us to iterate more rapidly. You can see here things like menus or buttons that appear on the screen. They're very natural. They work really well with the mouse. And in some sense, you can use hand control lasers to kind of point at things and grab things. As you can imagine, the sort of laser pointer that you might see in a presentation like this, imagine that you can actually point at something and then select it with that. What's really interesting about that from a user interface and human interface design perspective is that we're all very talented at using a mouse on a flat surface, on a fixed flat surface. But your wrist and your arms are actually not well designed to have precise control when you're pointing at something. And it's even more complicated if you realistically, project that ray across a room. You become less precise in your ability to do that. These are the types of pieces of tension that we deal with when we're trying to build these user interfaces. What we've ended up doing basically is we've kind of got a mishmash of both, because we do think that some designers are going to put on their virtual reality headsets and they're going to sit at a desk, and it's a much more powerful way to look at a three-dimensional environment, because you actually, one of the things, if you've done any three-dimensional design, one of the things that all three-dimensional graphic artists will do is a lot of the tools have sort of camera tools that allow you to tilt and pan your camera around your subject as you're editing it. And this is because you can't realistically get a three-dimensional, you can't really see the 3 dimensions on a 2D desktop unless you have those types of controls. In a virtual reality headset, of course, you don't need that. You can just kind of look in different directions and you'll actually see the three-dimensionality to it. But we can actually still give you those types of mouse controls, or those things that give you that precision. But when you're actually in the environment and you're trying to sort of walk around and experience it, we're actually moving to try to give you a much more tactile, hands-on type experience. And so, for example, we've recently introduced this notion of a tablet user interface that actually, in scale, has about the scale of an iPad size device. And, of course, we use the QML layer to actually put a web object inside the virtual world. We use off-screen rendering. All of our graphics are done using OpenGL, and so we use the basically an off-screen QML surface to be able to render the web page. And then that actually is a physical object that you can move around, and you can have it at any different angle, and you can interact with it using your hand to actually touch the object and scroll or select, and it works almost exactly like an iPad would in the physical world. And this has the benefit that obviously it feels much more like it's part of the environment, and so it doesn't break presence. It has the downside, of course, that you don't have that much precision. You don't have that much precision with the hand controller, and realistically, you don't have that much precision when you're sort of looking at that web page. We basically have to do, at this point, we have to do web page design where that web page is sort of designed with the concept that, hey, the person that's interacting with this has very limited control over where their finger is going to go. So, you got to make the interaction user interfaces much sort of bigger and sort of more, Playmobil type pressing on the object type thing. All right, so I know I breezed through that really quickly. But I want to kind of go through a few of the things that I'll just kind of rattle off some things that we are using today in our Qt layers, and then open the floor to questions for you guys. So, as I mentioned early on, we always wanted to be cross-platform, and so and we knew we had to have things like a multimedia layer. Now we could have done networking and things like that. We could have done that, just using sockets or something like that. Plenty of cross-platform support for that in the environments we use. But Qt gave us a bunch of functionality that allowed us to basically, the way that the sort of job scheduling, the idea of signals and slots, really made that type of processing a lot more straightforward for us. So the asynchronous development paradigm that we would need for this type of an application became much more straightforward. We almost our entire user interface is built using QML as the layout language. So we use QML extensively. We also use Qt for all of our multimedia layers as far as audio goes, audio input, audio output, which is important in our interactive high fidelity way. So anyway, that's kind of the headline. But I want to open the floor up to any questions that you might have. In particular, if you want me to, I am the CTO. If you want me to drill down into any particular things about challenges that we ran into in doing this, I'd certainly be willing to dive as deep as you want. Yes?
If you create this custom environment, how do you decide on where the position of a person in that environment is, and how to recreate the ambiance and not break presence from that?
Yeah. So first of all, there's a concept. I don't know how much you know about spatialized three-dimensional audio, but have you heard of HRTF? Okay, so look HRTF up if you haven't heard of it. It's basically this notion of you can model the way that the human head absorbs sound and hears sound. And there's there's a lot of great papers on that. We've implemented our own HRTF. It's probably the best of class, and it's also open source and Apache license. So if you need an HRTF, you always follow the Apache licensing to go get one. And so what HRTF basically allows us to do, and what we do in our spatialization of audio, is every sound source has a position in world. and every listener has a position in world, actually a position and an orientation in world. And so with that, you're with HRTF as well as with essentially the basic modeling of distance and angle of attack. You're able to basically model if someone's standing to my left talking to me and someone else is standing to my right talking to me, I will hear them balanced in each ear based on where they are. And the same is true for any sound source that we might put in our world. So, for example, we have people that have written scripts for, say, a flare gun. And so they have a model. Again, all of the objects are scripted in world using JavaScript as well, thanks to the Qt scripting engine. So somebody fires a flare gun off. The physics system that's built into our platform will calculate that trajectory of the flare as it shoots off. As the flare gun shoots off, where the gun is when you shoot it off is known. So everyone will hear that sound. As the flare comes falling down through the sky, it is in a place in the 3D world, and you hear it from that place. That's fine. I'll repeat your question. So the question was, what was the biggest challenge in establishing real time? First of all, a bunch of the team comes from, we're all a bunch of old grayed beards from the early wars of streaming media. So a lot of us know a lot about low-level network protocols and low-level multimedia engines. There's a couple challenges there. And actually, we just recently rolled out a beta update that deals with one of those challenges. But let me just sort of break down the challenges in general. So the first part is our main metric is round trip latency. So you and I are talking to each other. So how quickly from when I actually vocalize something will you hear it in your headphones? Okay, and we use because we are a large-scale system, so we don't do peer-to-peer audio. We actually, and because of the spatialization question that was asked earlier, we essentially do a server-based mixer. So what happens is each of us is sending a real-time feed up to the mixer, and then the mixer is essentially producing that spatialized, custom spatialized track for every single listener in the space. And so, needless to say, we've got the latency that's introduced by the sound card, the actual microphone. How quickly is the operating system layer going to essentially? How quickly do we go from the microphone into the operating system to our application layer? And Qt is sitting in the middle of that, so that certainly introduces an additional dependency on us. And then, of course, we've got to do whatever processing we're going to do to it locally, packetizing it, putting it in a network, sending it across the network. You've got things like the notion of network jitter that's happening all the time. And so your receiving side has got to essentially introduce a form of latency there to be able to handle the jitter, the natural jitter that you see across IP networks. And then finally, sending to you, the listener, and you have essentially that whole same chain in reverse. One of the things that we certainly have spent a lot of time on is how do you get. We actually chose Qt out of the gate because we didn't want to necessarily have to write custom Mac audio layer, custom Windows audio layer, custom Linux audio layer. Recently, we actually shipped we're currently running on QtWS16, the long-term release, long-term support release. But interestingly enough, in QtWS17, the Qt multimedia team introduced a WSAPI layer that allows you to, on Windows, allows you to directly interact with the multimedia devices in a much higher, lower latency way. So we just recently actually shipped essentially a backport of the WSAPI audio layer into QtWS16 for our platform, and that actually allowed us to shave off about 50 milliseconds on average off of the initial capture and the final playback. So that last stage of you've got the packets, you've got them in essentially an appropriate PCM format, and then you're actually pushing them to the audio device. There was 50 milliseconds of essentially buffering that Windows puts in that we had to get around by using WSAPI. Any other questions? Those are two great multimedia questions, not about user interface, but.
Did you have an issue with resolution for trying to use a tablet within your virtual environment? Because that's not a lot of text for the overall.
Yeah, it's really interesting. That's a great question. So the question was, did we have a resolution with issue with resolution of the tablet? What's really fast, what we discovered pretty quickly is that it's very natural for somebody to essentially take an object in world and just hold it up to their face, and that's really what people naturally wanted to do anyway. And of course, once you do that, you actually have plenty of resolution to do that. Now, that being said, our biggest resolution challenge has to do with the precision of your hand as you're going to interact with the object. So our platform is essentially hardware agnostic, and we've built in many layers to allow us to many interaction points that would allow us to work with leap controllers, or so the leap, of course, is essentially a depth camera based solution for actually seeing your hands, and it essentially does computer vision to then pick out your fingers, so you can actually get all 5 fingers with the leap. Devices like the Oculus Touch, which is shipping in December, or the HTC Valve, the Vive controller by HTC and Valve, it's just a hand, so it's a single position in space. Now, they've focused a great deal on really detailed tracking in room space for that, but it's essentially it's essentially like you're interacting with a user interface with your fist, right? So it's not actually about video fidelity or resolution of the pixels as much as it is about giving user interfaces that you can interact with your fist or with a laser pointer. Any other questions? Well, realistic or appropriate. So the question is, what sort of challenges have we run into in doing avatars in virtual reality? It's a really good, interesting question with a lot of debate around it. You know, of course, the biggest challenge with virtual reality and avatars is the uncanny valley. How close to realistic do you get before people actually have a negative visceral reaction to something that's too realistic but not actually real? And what we found is that, interestingly enough, this final photo is a photo of a photoreal avatar of our CEO, Philip. It was produced with I think it's a 800 camera array that actually can shoot a subject from all sides. And we've implemented things like subsurface scattering on a skin shader to give skin a much more realistic effect. So there's a lot of great state-of-the-art work that's being done in how do you make computer graphic generated content look more realistic. And our perspective on this is that some people like to just show up in a cartoon, and some people like to show up as a dragon, and that's perfectly okay. And other people are going to basically try to drive towards more and more realistic representations of themselves. Because we're an open platform, we're not necessarily trying to have it would be a little bit like the Apache team saying, well, we only want people to use our web server if they only put photos up and not drawings or cartoons, right? So our perspective is whatever people want to use, they can do it. And our platform is essentially open to let you put whatever avatar you want in there. We don't make you pick one of our avatars. But yeah, I mean, the other thing that we've spent a lot of time on with avatars actually is the how do you map those hand controllers or the leap hands or body movements in the physical world? How do you map those onto your avatar in the virtual world? And we're a big believer in basically going the whole way, full IK, full as realistic as possible. It's a big challenge, and we've certainly got a lot of work to do. What you're seeing in a lot of other sort of VR spaces is they're essentially kind of punting on that challenge and saying, well, we're just going to do head and hands, right? That's what we know. We know where your hands are. We know where your head is. That's what we're going to do. But again, we believe we believe that there are solutions for full body IK that will actually get your avatar to look very realistic. 35 seconds. Oh, one last question. I'll see if I can answer it quick. So the question is, do we do anything with real-world objects coming into world? There's a couple different hardware manufacturers out there that are doing some sort of object tracking. And our platform certainly would support that. We think that's a pretty interesting and exciting idea. There's, again, our perspective is we're completely hardware agnostic. So if you're working on hardware that allows you to track real world objects and you'd like to work with us on how to help people get that into the platform, then we're all for that. You can do that today with things like the 6sense SDK as well, and Vive is actually starting to sell trackers that work with their Lighthouse technology, and so those will just work in our environment today. 0 seconds. Well, thanks a lot. Hopefully, I didn't talk way too fast.
Yeah.
And
let's give a round of